Okay, welcome back to EL166 again. Here we are. We're looking at the Experiment 9, Part 1. What I'm trying to get you guys to let me see here. The word I'm looking for. The next experiments we're going to be fooling around with is data word manipulation or bit word manipulation a little bit. We've done a little bit of this in the past, but we're just going to kind of go through it a little bit here. What I've got going on is essentially in Experiment 9, Part 1, you'll see the challenge is to count between 0 and 15 once every second. And what I want to do is make sure that when you're doing this, that you're using values such as 15. I don't want to see a value of 16 to count to 15. Again, we got to make sure our programs make sense. So if we're using a counter, for instance, as soon as we hit that reset, remember when you hit that reset, it's going to set it back to 0. So as soon as it reaches the done bit, it's going to set that back to 0. So if you decide to use the counter instead of math, which is fine, just make sure you understand that it will reset that value. You will never see 15 turn on. That's kind of one of those pieces I'm looking for. The next piece of this is that I'm using the first 4 bits of this word to illustrate the count in the output data word. So we're counting to 15 using the first 4 bits. We're using the next 3 bits to indicate what part of that count we're at. And you can use limits or equals 2s or greater 2s or less than, or however you want to do it to establish the bit set here that to turn on and off here. The challenge, part of the challenge is to understand that the information here, if you write the whole word, is going to write the whole word, right? It's going to write fill in these 4 bits and the rest of these with zeros. So you can use a mass move. You can use some different techniques to incorporate this. I'm just kind of curious to see what you guys come up with. I don't want to give away all my secrets, but there's some pretty neat ways of doing this very thing without getting too creative, but this is what I'm looking for. Basically, you're counting in binary to 15. As you can see, it's incrementing 7, 8, 9, 10, 11, 12, 13, 14, 15, and back to 0 again. So as you can see, it's all it's doing. So this is a fairly easy exercise, but it gives you another level of, I got to make sure that this information doesn't overwrite this information. That's what I'm trying to get to with this exercise, okay? All right, have a good time listening, guys. Talk to you, bye. All right, so we're moving into Lab 9, Part 2. This is a process. It's difficult only in the sense that it requires multiple steps. The idea behind this is to get you guys thinking word manipulation and how it is impacted by different steps of the process. So what we're looking at here is a series of registers. I've got, I just went through and labeled a few of them, A, B, C, and D. And then registers, meaning this is the same thing as a word or double integer. It's just basically a place to store some information is the term register. So you'll hear the term register used quite a bit. So I use registers quite a lot. I call it the term registers when I'm thinking about word manipulation. So that's where you probably hear the word register mostly. So let me pull over the requirements for today and review those real closely with you. So first piece of this, we have to run a 3-step process. Each step of this has to be indicated by a 1, 2, or 3. So it's not just turning on a bit, but it's turning on a a binary value. So if we're running step 1, we're going to run a binary value of 1. If we're running step 2, we're going to run a binary value of 2. And if we're going to run step 3, we're going to run a binary value of 3. Okay, so what does that mean for us? So that means that our first 2 bits of our output data word are utilized now. That means that if you really looked at it closely, it would be those first 2 bits are, we can't overwrite those. So this is one of those points that I need to start thinking about. We talk about the mask and the mask move and that a little bit. So this is where, like, when we have to write information to a location, we got to make sure that we're only writing to the bits that are valid. So what I would recommend doing is maybe using a mask move. When I move a 1, for instance, into the output data table, I could use a mask move and make sure I'm only sending the 1, or I actually set my mask to a 3, so every time I send a 1, 2, or 3, I'm only looking at these first 2 bits. So you can adjust that to whatever you want there. So again, here we have that cycle start. Now this is this piece here, the cycle start. You can see here, all I did for my cycle start is I used an integer word. I put in some other test bits in here so I could disable other pieces of my logic. So I could just so when I started it here, this is my start bit. And I put a 1 shot in front of it, so if I leave it on, it doesn't continuously run. So when I start my system, it's just a simple seal-in start circuit. So that's pretty straightforward. The next piece of this, so that's the system start. So I hit that bit that I have highlighted there with my start. I have a stop. So if I hit the stop, it stops the system and clears the registers. So just pretty good practice. When you stop a system, it's not necessarily always a good practice, but in a practice like this where we're just manipulating data and you want the data to start fresh every time, clearing the registers does make sense. If you're running a machine, for instance, and you stop the machine, you really don't want to clear that data out, because why? You would lose all your information of where the machine was located, what was going on with the machine. And so when you go to start up, you have to do what? You have to rehome everything, start from 0, and nobody wants to throw all that scrap steel out, so, or scrap a bunch of material, whatever it is it happens to be. Okay, so that's the start-stop process. So once we started the process, we go ahead and we kick on step 1, which would what? Turn on, first thing we would do is we would be writing a value of 1 to the output data table saying, hey, I'm on step 1. We're going to do a real simple count here. We're going to count, add 1 count to a register, and then move that value to register A when we've attained that count. So that's kind of what I was thinking there. You can write right to A if you wanted to. Just make sure you understand what's going on there. Reset the count when 10 so again, the problem, if you use 10 A, you got to make sure you set A's information, because once you reset that count to 0 when it reaches 10. So that's kind of why I'm saying you're probably going to want to do the count, move it to register A, and then reset the count, so you're not losing that information in register A. And we start process 2. Here we're going to turn on the send a 2 to that output data table, and again I would use a mask move. Send a 2 to the output data table. We're going to multiply register A by 5, so just the information we stored here is going to get multiplied by 5. And now we're going to do a countdown. Now, what I did in this particular case is I just used a counter. It counted down by 1, or excuse me, I'm sorry. I used a subtract and a counter. So as soon as the count reached, every time the flasher flashed for 1 second on, it counted 1 and it subtracted 1. So you can do it any way you want, but that's what I did there. And so we get essentially a subtract 5 pieces from this count. We're not just subtracting 5 from it. We're subtracting. We're counting done 1, subtract 1, subtract 1, subtract 1, subtract 1, up to 5. I'm sorry. Yeah, so we count, and so that drops our value by 5, and then we subtract a total of 10 and place the value into register B. It is at that point we start step 3, which is going to put we're going to move a binary 3 into the output data table. We're going to divide register B by 5, place results in register C. We're going to add all 3 registers together and store it in register D. We're going to shift register D left 1 bit each second 4 times, moving in 4 zeros. So if you're thinking about this whole thing, we're taking and we're clearing that first 4 bits for all this information here. Okay, this process, these running steps. So I'm just cleared 4 bits, so we wouldn't be overwriting that. But again, remember, when we move this information, we place this information in the output data table, we got to think of it. We can't just move it there, because what will happen is we'll overwrite that information that we're using for accounting. Again, think about that mass move. Think about how that works and how that's going to get us where we need to be. We display the results in the output data table for 10 seconds, and then we clear everything out and we complete the cycle, resetting the cycle start. So that's all we're looking to do here. That should cover about everything. I hope that, I know this is, the wording on this is difficult. It'd be easier if I did all the math and showed you exactly how to do it all. But I need you guys to kind of develop some of these ideas, develop some of the systems, and understand what word bit manipulation is. And that's what this exercise is for, to get you better acclimated to dealing with words and bits and how they interact, and how, if you overwrite them, what kind of troubles that causes you, and that kind of thing. So that's the point behind this. I hope you find this to be a little bit challenging, and pull some good understanding of how bits and words interact, and if there's a overwrite or something of that nature, it can be challenging to find at times. It can cause issues that you really gotta play around with to figure out. So, all right. Well, hey, best luck to you guys. I'll be talking to you soon. Talk to you. Bye bye. Okay, so here's the program that I've got going on. I'm just going to. I've got my first bit here. This is my start bit. I got a 1 shot in front of it, so I have to turn it back off, then back on again. As you can see here, I have registers A, B, C, and D. And then I just threw in a couple of other pieces that I'm using to store information. Let's see how this whole thing plays out. So just so you guys can see what I've got going on here. So basically, my first register is counting to 10 for part 1. You notice down here, my output data table is indicating that I'm in step 1 of my process. I reach the value of 10. It puts that value here into A, and then it starts counting down. As you can see, I started process 2. Now I'm into process 3. I divided that by 5. I moved the registers over to the left, and now you can see that it populated here. So that is how it all works. Waits for about 10 seconds, clears out the whole thing, and we're in business. So that is that process.